Welcome to the deep dive.
Yeah.
Today, we're doing something really exciting, actually, and a bit different.
Yeah.
We're taking a deep dive into your upcoming book, Unsupervised Machine Learning with Python.
Yeah.
Ahmed Khorshid, that's you. As you're prepping this for Amazon KDP, we get this amazing chance to look at the blueprint.
The outline, the intro section.
Exactly.
Yeah.
The core of it. So our mission today is to really pull out the key insights, give a fresh look at what makes your book stand out for its readers.
Yeah, it's a great opportunity, I think, to look at how a technical book like this is put together strategically.
Right.
It's not just like summarizing. It's about connecting those dots. Why will people find this book essential? What's the unique angle on, let's face it, a really critical part of machine learning?
Yeah. What impact is it going to have?
Exactly. What impact it's poised to make.
Okay. Brilliant. Let's unpack this then. Starting right at the heart of it, unsupervised learning itself. That title, Unsupervised Machine Learning. It really invites readers into this world of, finding hidden stuff, doesn't it?
It does.
Unlike supervised learning, which needs all that labeled data, this is about working with the raw, unlabeled information, finding patterns, structures.
Things you didn't even know to look for.
Right, like customer segmentation or spotting fraud. Now, for someone tuning in, maybe they know the basics. What's something surprising or maybe the common misconception your book tackles early on?
That's a really good question. And it's exactly why your book right up front emphasizes the real-world need for unsupervised learning.
Okay.
The maybe surprising truth, most data out there just is unlabeled. Supervised methods are great, but getting that perfectly labeled data, it's often expensive, takes ages, or it's just impossible at scale.
Right. Resource intensive.
Totally. So your book's intro nails this. Unsupervised learning unlocks this huge ocean of unlabeled data. The key insight, I think, is its exploratory power.
Exploratory.
Yeah, it's not just about getting answers you already expect. It helps you ask better questions, like discovering totally new patient groups in healthcare data, things nobody saw before, or finding patterns in how people shop that spark new product ideas.
So discovery, not just confirmation.
Exactly. And it's also vital as a pre-processing step, reducing dimensions to simplify things, or clustering data first. Both can seriously boost how well your supervised models work later on. It's about making sense of the chaos, really.
I like that, making sense of the chaos, not just labeling the known. That really clarifies it. So thinking about you, the listener, about to publish this, who is this guide really for? A good book knows its reader, right?
Yeah.
And your outline suggests a pretty diverse group.
It does, yeah. It's very intentionally designed for a few different groups, but they overlap. First up, aspiring data scientists, ML engineers.
The newcomers.
Sort of. New to unsupervised, maybe, but they need basic Python. Loops, functions, the usual stuff. But, and this is important, no prior ML experience needed. Your book starts with the basics, the core ideas like clustering, and then builds up gradually.
Okay, so a gentle on-ramp. But it's not just for beginners, is it? What about people already working in the field?
Definitely not just beginners. For industry folks, analysts, engineers, researchers, your book packs in deployable solutions. Real-world stuff.
Like what?
Like fraud detection pipelines you can actually use, customer segmentation models, anomaly detection systems, and it stresses reproducible code, so it's immediately practical.
Got it.
And then for academics, educators, the structured chapters, the review questions, the references to key papers, it makes it really suitable for courses or just deep self-study. It bridges theory and practice quite nicely, I think.
And I saw that bridging chapter for absolute beginners. That seems really smart. For someone who only has basic Python, what's the biggest mental hurdle you think that chapter helps them overcome right at the start?
Yeah, that was important to include. I think the biggest hurdle is just that mental shift, From supervised, where there's a right answer, to unsupervised, where there isn't one clear target.
Oh, okay. The ambiguity.
Exactly.
Yeah.
So the bridging chapter tackles that directly. It demystifies how you even approach data without labels. Talks about similarity, distance metrics, why pre-processing, like handling missing values or scaling features, is maybe even more crucial here.
Because there's no target variable guiding you.
Precisely. It just makes that leap feel less intimidating, builds a solid footing before you hit the complex algorithms. And then that how to use this book section reinforces it, right? Encouraging people to code along in Jupyter, experiment with the parameters, apply it to their own work.
Active learning.
Yeah, it's all about building that intuition by doing.
That hands-on approach sounds ideal.
Yeah.
Which flows perfectly into the book structure. It looks like a really guided journey you've mapped out. How does that flow work to take someone from basics to the cutting edge without, losing them?
It's very deliberate, yeah. Designed for steady progress. Part 1, Foundations, that's chapters 1 to 6. That's the intro, a Python refresher specifically for ML, data preprocessing, then the core algorithms. K-means, hierarchical clustering, DBSCAN, setting the stage.
Okay, solid foundation, then part 2 ramps it up.
Exactly. Advanced techniques, chapters 7 to 12. Now you're getting into dimensionality reduction, PCA, t-SNE, UMAP, anomaly detection with isolation forest, one-class SVM, association rule mining, and really importantly, how to evaluate these models.
Evaluation. That's often tricky and unsupervised, right?
Super tricky. So that chapter's key, making sure you're not just running code, but understanding what the output actually means.
And then part 3, cutting edge trends, chapters 13 and 19. That feels very forward-looking. Self-supervised learning, ethics.
Yeah, got to look ahead. Plus practical stuff like cheat sheets, case studies. It rounds it all out. But that whole structure, including that bridging chapter we mentioned, is designed so someone starting with just basic Python can get comfortable with the core supervised versus unsupervised ideas and data prep before they really dive into the algorithms themselves. Each step builds on the last.
Okay, so for someone listening, wanting to really get their hands dirty with the algorithms, how does your book help them apply these things, not just read about them? What's in that toolkit?
Yeah, the toolkit. It dives deep, but always with that practical focus. For clustering, take k-means. Your book explains minimizing the within-cluster sum of squares, basically making clusters tight.
Okay.
But it doesn't stop there. It guides you on picking the right number of clusters. Elbow methods, silhouette, score, and importantly, when they might not work well. Then hierarchical clustering, explaining dendrograms visually, when to go bottom-up versus top-down.
And what about those density-based ones, like DBSCAN? They can seem a bit more complex.
They can be, yeah. So the book highlights their strength handling, weird shapes, ignoring noise. But crucially, it guides you on tuning parameters like EPs and minfits. It's not just definitions. It's about how to tune them effectively on real data, maybe showing how a small tweak changes everything. That practical advice is key.
That tuning advice is gold. Okay, what about dimensionality reduction? Often feels like a black box.
Totally. The book tries to open it up. PCA explains how it maximizes variance, capturing the most info. Then t-SNE, great for visualization, preserving local structure. It explores perplexity, that key parameter, how tuning it changes your plot.
Right, I've struggled with perplexity before.
Haven't we all? And then UMP faster, keeps both local and global structure. The book compares them, helps you choose the right tool for the job, whether it's visualization or just pre-processing.
Makes sense. And for anomaly detection, that's huge in many industries. Isolation forest, one-class SVM. Any unique angles there?
Yeah, for isolation forest, it clarifies that core idea. Anomalies get isolated faster in the trees, shorter paths, simple but powerful. Contrast that with one-class SVM, which uses kernels, better for nonlinear stuff, helps you decide based on your data. And for association rule mining, finding those people who buy X also buy Y rules. It goes beyond just defining support and confidence. It's about interpreting them to find rules that are actually useful, using a priori or FP growth, and avoiding common interpretation mistakes.
And you mentioned case studies, chapters 11 and 18. That really connects the dots, doesn't it? How does the book make sure these feel real, not just academic?
By tying every algorithm to something tangible, finance, fraud detection with isolation forest on real transaction patterns, K-means for customer segments based on spending, healthcare, clustering patients from lab results using hierarchical clustering, using PCA or t-SNE on MRI scans.
What about Industry 4.0? Lots of sensor data there.
Absolutely. Anomaly detection in IoT sensor data for manufacturing, self-supervised learning for robotics, clustering for optimizing smart grids, even topic modeling on customer feedback using BurTopic. And the hands-on part comes from all the Python code snippets woven throughout. It's always pushing you to implement and tinker.
Okay, implementation is key. Which brings us back to evaluation, chapter 12. You said it's tricky without labels. So how do you know if your unsupervised model is any good? What's the book's philosophy on validating these models?
That's the million-dollar question, isn't it? The book pushes a multifaceted approach, no single magic metric. For clustering, yeah, it covers internal metrics like silhouette score, how tight are my clusters, and Davies-Bouldin. If you happen to have some labels, it talks about external ones like adjusted RAND index.
Okay.
For dimensionality reduction, things like reconstruction error for PCA or trustworthiness and continuity for t-SNE basically. Did it mess up the neighborhood structure too much? For anomaly detection, precision recall curves, ROC, AUC scores.
So a range of metrics depending on the task.
Exactly. But the core philosophy really is that numbers aren't everything. It heavily stresses visual validation, heat maps, t-SNE plots, UMP projections. Looking at the results is crucial for building intuition and catching things metrics might miss.
Right, seeing is believing, or at least understanding.
Mhm.
That makes sense. And the book keeps going, looking at cutting-edge trends in Chapter 13. The field moves so fast. How does your book prep readers for what's next?
Yeah, you blink and there's something new, so it gives a taste of what's emerging. Self-supervised learning from unlabeled data cleverly, contrastive learning, generative models like diffusion models,
Wow, okay.
even touches on graph-based methods, neural architecture search specifically for clustering, and way out there, quantum machine learning. It's not exhaustive, obviously, but it's about giving readers that forward look, hinting where things are going.
And it seems like you really support that continued learning journey with all the resources mentioned later.
Definitely. The book's meant as a launch pad. It points to key Python libraries, TensorFlow, PyTorch, GenSim, HDBSCAN, public datasets to practice on MNIST, Iris, ImageNet, good online courses, key research papers, forums like Kaggle, Stack Overflow, Reddit, connecting you to the community. Plus, practical aids like the definitions of key terms and that unsupervised learning cheat sheet. Those are designed for quick lookups when you're actually working on something.
It sounds incredibly thorough. Seriously. Unsupervised machine learning with Python.
Yeah.
It's shaping up to be much more than just a textbook. It feels like a really practical, hands-on guide that also keeps an eye on the future, designed to get readers building and deploying with real confidence. So congratulations on getting this ready for KDP. It really seems like it's going to be a fantastic resource for so many people.
Thanks. You know, unsupervised learning, it really is both an art and a science. It's this journey of finding patterns you didn't expect in the data. And hopefully this book helps people not just see those patterns, but actually interpret them. Like John Tuckey said, the greatest value of a picture is when it forces us to notice what we never expected to see.
That's a great quote.
Yeah. And that's kind of the goal here, right? Helping readers use these tools to notice things, to extract meaning they didn't even know was there in their data.